So good evening everyone. So as a part of PMRF TSIP, so this is the second session where I'll talk about the some questions and answer on advanced chemical thermodynamics and kinetics. As you know that in previous session we have covered some question. In this session also we'll cover some questions and followed by answer. So we'll start like that there are so many molecules that can be polar and non-polar as well, and based on that we can get the instantaneous dipole moment of the molecule, and as a result of which we will get this whether this molecule is basically has a dipole moment, this is polar or non-polar. So if you see a molecule made of both the same homoatom, that is nitrogen nitrogen, so this is dinitrogen molecule where the another is CO2 which is also made of a carbon oxygen oxygen. So these first two molecules are non-polar, but if you see that HCl, water and HC, they are polar molecules. So if there is a difference between the dipole moment created in the inside the molecule, then you will get the molecule as a polar, otherwise you will get non-polar. Let's say if you consider CH4 which is a tetrahedral which is also non-polar. Now this is the first example where you will have this which is the most polar molecule among these. So you have the SO3 where you can get a C2 axis, C3 axis on S. So this is basically planar molecule. So this is planar, and you will get overall this molecule as a what? This molecule as polar molecule where this is also a polar molecule. Okay, so if this SO3 is non-polar, where this here also all XCF bond and all the bonds are polar, but there are lone pair also. So as a result of which you will get this XCF4 is also non-polar, but this SF4 is polar molecule where you have the lone pair and you have the resultant the dipole moment. As a result, this is a polar molecule. Now go to the another. So if there are two values of this dipole moment vector, so q and there this is a xi and yi, and if there is a like what I say, I will say that if they have a particular this particular electric what is called this charge, then you can get this mu x and mu y. So they are basically the summation or scalar addition of this charge into distance. So these are the two xy plane where 4e at 0 0 and minus 2e at this 162 pm 0, and minus 2e is an at electron of 30 degrees Celsius. So you will get this value mu x and mu y, which are the dipole moment vector along x and y axis. You know this is a very dipole moment is a vector quantity, and just you add it, you will get a resultant dipole moment. So this is the magnitude where mu x plus mu x whole to the power half, you will get this value of around 9.45 into 10 to the minus 29 coulomb into meter. So this is the mu, that is the resultant dipole moment. Now if you connection this theta equal to this nothing but tan inverse mu y by mu x. So this is the same as the theta which we used to calculate from the scale from the 2D coordinate, that tan theta equal to y2 minus y1 by x2 minus x1. So here the correct option is the A is the first option, like a first option. Now I will go to the another problem where you take air at 20 degrees Celsius, and you are allowing that air to go through a tube of 1 centimeter diameter as a so as a result of it is a quite tricky problem, as a result of which you will get what is the value of this Reynolds number. So this Reynolds number is, so this is a question, this is a previous year's question. So this Reynolds number is written as k into eta by rho into r, where k is the value which is considered as the Reynolds number 1500, and eta is nothing but the what is it, it is nothing but the value which takes the around 181 into 10 to the minus 6 point, and this is the rho is the density, and this is the just diameter, means if you divided it by 2 you will get 0.5 centimeter. So this is radius. So as you can calculate this maximum velocity, where you can get this number around 417.7. so this is the correct answer is B. So this is the 1500 into 181 into 10 to the minus 6 gram centimeter into second inverse. Below is density gram into centimeter to the power minus 2, as a result of which you will get the centimeter minus 2, and denominator you have centimeter minus 1, so minus 1 plus 1, so you will get this centimeter and second inverse. So this is the unit of a volume, unit of a what I will say maximum velocity. Now I will go through another question, so I will quickly go through, then we will have some discussion with along each other. So this is the dipole moment that you need to calculate when the applied field density is 18 kV into meter to the power minus 1. So this is the field that is imposing per unit area, per unit distance, and the polarity velocity of ammonia is 3.33 into 10 to the power minus 30 meter cube. So this induced dipole into is equal to alpha into epsilon equal to epsilon, which is equal to basically 4 by epsilon 0 into epsilon prime into epsilon, and this phi is the 3.14. this epsilon is a very standard value, which is 8.854 into 10 to the minus 12 for this SI unit, and alpha prime is already given here as a polarity 3.33 into minus 30. So this is a meter cube already in SI unit, and this is the whole into meter to the power minus 1. This is also a unit in the SI unit. So as a result, if you do calculate, so you will getting the you will get the value around 6.6 into 10 to the power minus 6 coulomb into meter. Okay, so this coulomb into meter is the unit of your dipole moment. What is dipole moment? Dipole moment is the vector quantity that you can calculate by the distance between two charge atom and distance in between them. So this is the distance and this is the charge, 6.6 into 10 to the power minus 10 to the power minus 36. Okay, now you come through the another that calculated the relative permittivity of the liquid whose molar polarization is 26.21 centimeter cube into mole inverse, and the density is 0.898 gram into centimeter to the power minus 3 at 0 degree Celsius. Now you have to take the consider that this molecular weight is 64 gram into 10 to, into per mole. So you need to calculate the relative permittivity. So this is the formula for the relative permittivity, equal to epsilon r minus 1 by epsilon r plus 2 equal to rho into rho m by m. So this m is the molecular weight and this is the molar polarization, and if you do the calculation you will get this value around this is the molecular weight, that m, and this pm is the molar polarization. Molar means the polarization that happens per mole of the substance, so which is coming as 26.21 already given to the questions. Now 0.98 is the gram per centimeter, which is the density. If you do calculation, so your centimeter to the power minus 10 to 10 into centimeter cube, that will be cancelled, and gram will be cancelled, mole cancelled. So basically you are getting the value which is a unitless value around C. Now from there just you have to calculate the epsilon r. For that 2 into 0.401 plus 1 by 1 minus 0.401, so which is coming around 3. So this epsilon r is coming from this equation, where you can write that epsilon r equal to 2 into C plus 1 by 1 minus C. Okay, so just a minute, so let me know if you have any question. So if you read this, so this here only this SF4 has is polar molecule, but the others is not. And here the value is coming around, the answer will be the A answer, the 9.4 into minus 29 kilometer meter in 194 degree. And here this you need to calculate only this maximum velocity, which is coming around k into eta by rho into r, and this value is coming around 417.7 centimeter into second inverse. So this gram will be cancelled out, and 7 to the power minus 1 by 7 to the power minus 3 plus 1, so minus 2 over it will go up, so centimeter into second inverse. Now here you need to calculate the dipole moment. Everything is given, 4.5 epsilon 0 into alpha prime, which is the polar variability, into epsilon, and you will get the value of this induced dipole moment, 6.66 into 10 power minus 36. And this question, just you need to calculate the value of C, and if you know this 2 C equal this epsilon equal to 2C minus 1 by 1 minus C, 2C plus 1 by 1 minus C. So this is coming from this previous, from this equation only. Just if you do little bit rearrange it, so you will get the value around of it. Now I'll go to another question. So here you need to calculate the positive and negative charge in a 350 ml flask of water. You know, water is made of this 2 hydrogen and 1 oxygen atom, which makes water molecule, and they have given the volume of water is 350 ml, and now in one need to calculate the mass of water is 350 gram, because density of water is considered 1 gram per ml, and molecular mass of water is 80. Molecular mass means it is 80 gram into mole inverse, that per mole, 80 gram per mole. So you know that per mole their water molecules will be 6.023 into 10 to the power 23, and you can calculate the molecules of water around in 350 grams. So that is very quite easy. You know that in 80 gram you will have this water molecule 6.023 into 10 to the power 23, and per gram, so this is basically dividing by 18 gram, and you will get the value amount of water, like mass of water, which is around 350 gram. Now one molecule of water contains 2 hydrogen and 1 oxygen atom, so 2 hydrogen and 1 oxygen atom, so overall it has oxygen has the atomic number of 8, right? So 8 plus 2, 10 is the total number of proton, and 10 also electron, because water molecule is overall neutral. Now if you see OH minus, so what you will get in OH minus, you will get basically one proton less, and you will get the value of around 8, right? So because, but the water is a very neutral molecule, so overall you will get this total number of molecule, total number of electrons is 10, and the proton is 10, right? Now you need to calculate the positive and negative charge. So electron is negatively charged and proton is positively charged. So magnitude of positive charge equal to magnitude of negative charge, magnitude of each charge equal to molecules in 350 gram, right? You know already molecules, since you have calculated from this formula, where you will get the molecules around 117.11 into 10 to the power 23, and if you multiply that value into 10, because 10 is the proton, and each this charge of each proton and electron, so this 10 into charge on 1 unit proton or electron, so overall you will get 117.11 into 10 to the power 23. So this is the molecule that present at 350 gram of water, and if you into 10 into, and the what the charge of a proton or electron is 1.602 into 10 to the power minus 19. So this is the value that is in SI unit. So overall you will get each charge is 1.87 into 10 to the power 7, right? So so the calculate positive 1.87 into 10 to the power minus 7, right? So this will be the answer, 10 to the power 7, right? So A is the answer here for the question. A is the answer. And let me know if you have any question. Now you if you are told to calculate the number of charge in, what I will say, in 15 gram of methane, okay, what would be the value? So as you know, this 15 gram CH4, just you need to calculate what is the value of let's say not 15 gram, so let's say this is 16 gram, okay, for the sake of 60 gram of CH4, correction, right? So so in this case you have to consider that the molecular weight of CH4 is coming around 16 mg, right? So if it is a 16 mg, so 16 mg is the molecular weight, so basically this is the same as the its molecular weight 16 12 plus 4. Now carbon has 6 proton and 6 electron, and hydrogen has 1 electron 1 proton, right? So 6 plus 4 equal to, then also you will get 10, right? So 10 number of protons and 10 number of electrons is present in each molecule of CH4, right? Now this gram of CH4 means how many molecules of CH4? 6.023 into 10 to the power 23, right? In that molecule you have, each molecule you have that number, right? Then 6.023 into 10 into 1.6 into 10 to the minus 19 coulomb. So that is the value, right? Now I will take to another question where you will have now estimate the refractive index of the liquid having polarizability volume 2.2 into 10 to the power minus 30 meter cube and density is 865 kg per mole at optical frequencies. The molar mass of liquid is 72.3 gram per mole. So how we will calculate the value of this refractive index here? So this is the formula. This is a very typical formula, but in exam it should be provided, I feel so. I don't know have this or question pattern also. So if you do all the calculations, so you will get this value around 1.10. So this is the refractive index of the liquid which has the polarizability volume 2.2 into minus 30 meter cube and the density is 865 kg per meter cube. So this is a very standard example where you can see that each refractive index depends on these different factors. The molar mass of liquid is 72.3 gram. Okay. Now you need to calculate the electric dipole moment of a system where proton and electron are 212 pm apart. Pm means picometer is apart in the plane of the paper. Now you have to calculate the electric dipole moment for a system where proton and electron are 212 pm apart in the plane of the paper. So this is the formula where you have this charge and you have the distance q is the magnitude of the charge and its value is for electron and proton is 1.6 into 10 minus 19. So this is the charge of each proton and each electron. Now they are apart by 212 pm. 1 pm equal to 10 to minus 12 meter. So you have to convert it to this value of SI. Now you will get the value around 3.39 into 10 to minus 19 coulomb into centimeter. Now in the previous case, if you look at the previous case we have calculated, so this is the 6.666 into minus 36 where you are also calculating induced dipole moment. Now here you are calculating direct electric dipole moment, right? So induced means in the presence of that particular electricity, what is the induced dipole moment to the other particle sitting next to it? That is the induced. Sorry, just a minute. Now these are the questions. Now let me know if you have any query. So this is the polar and non-polar molecule, and these are the like molecules which is polar and non-polar. Now you tell me whether this how I will say each HT is polar. Sorry. HT polar means deuterium. So instead of hydrogen, so hydrogen has 3 isotopes: hydrogen, deuterium, tritium, and is HH is not polar, that we know, and the HT is polar or not, that you need to say. So HT is polar basically. It is polar. Yes, HT is polar. It's polar. But is not polar. If non-polar. Because I need to confirm so my recording is going on. Okay, now come to the another question that here they have given this in xy plane, right? Now if it is in yz plane, what will be, what will be the approach? Should replace x with y coordinate and y with z, then basically both the xy plane can be converted to xz plane. Just you rotate it 90 degrees, so your xy plane will be converted to xz plane. Okay, so just you need to rotate it at 90 degrees. Now this question is also a important question, but here you need to remember the value of this Reynolds number, which is generally 1500 is considered, and you know this rho, and you know this. Okay, here is a good questions. Okay, now if higher density, what I will say, higher density fluid is fluid is channelized through some diameter, so which, like, let's say rho 1 rho 2 2 rho 1 greater than rho 2, so which has the more critical, like more turbulence velocity? Rho 1 rho 1 and rho 2, rho 1 greater than rho 2. Obviously if more is the density, less is this turbulence, right? Maximum velocity for turbulence. Okay, so as a result of which we will get less density means more turbulence, low density means higher turbulence. Just they are proportional to they are inversely proportional, right? Okay, so this is also simple. So now you have already a particle charged something, now it will induce to the other particle something, so you need to calculate what is the induced dipole moment there. And for that, you know this that very standard constant value, this epsilon 0 is 8.854 into 10 minus 12, and as a result of which we will get the value of around 6.6 into 10 minus 36, right? So these are the questions. So now you need to calculate this calculativity. This epsilon r equal to 2c plus 1 by 1 minus c, right? So this c you can calculate from here. So these are the questions for this session, but we will go through some other questions also. So let me know if you have any questions from here, if any questions is there. So this is a very important. So this is just nothing but you need to calculate the resultant value mu x square plus mu y square into all to the root over of that value. So you will get this magnitude.